Okay. In example 4, we'll discuss how to use struct. Struct. This is a keyword for declare structure. Use struct to store the data into the tree here. Sometimes you will see someone write a code to use the structure right into root file here or tree file here, but it's not recommended because sometimes it's hard to protect your data. It's recommended to use class because class you can set as private variable, so you can only use the method like set value something to access that data or get the data or to change the variable private variable here. But anyway, but because it's not uncommon to see to use structure to write into a tree, so I would demonstrate here. So use a struct. You can save into a branch or link into a branch with several leaf. We will discuss that later. Okay, so first thing is to know how to declare a structure here. It's quite simple. So you have to use a keyword struct and the name you want to say that's this structure. Now I call this particle struct. This is for my preference. I like to put the capital struct here to let me know this is a structure here. Sometimes I would say this is a class something the same way because it's easier for me to recognize what's the type of this. So in this structure here, there is a two uh, variable. One is a float type variable here. One is a float type array here. So remember in this statement here, you need a semicolon here. Otherwise, you will get a syntax error. Alright, so we copy it and paste to the root. Hit enter here is fine. So we declare a structure called the particle structure here. So we use the particle structure to create a thing that we want. So that's we say particle structure. Now root knows that there's keyword here, and then they give a name like say as particle or strange particle something. This is okay. Uh, okay, good. Now we can use this as long point like as particle dot energy equal to 10. Now we can see what happened. As particle energy, we see this is 10. We just make it 10. Now it's 10 here. Once we declare a structure of this variable as a particle structure, it will automatically have the variable called energy and position within s particle variable here. And you have to use the dot operator here to access this two variable. So the same thing is we call the now which position 0. Now we don't change anything, it's supposed to be something weird. So the thing is you say is let's say is the 1 and do it again is 1 here. Now you know the how to use the structure right now. So the next step is to link create a tree and link the structure the S particle within the tree here. So let's create a tree here. So the tree I call it T here, and the key is T as the same object name here. And title is a simple tree with struct. Okay. Now the next step is to link. Alright. So in this case, we have two variable. One is energy, another is position here. So I create a true branch um, to store it. Actually, I can create a one branch, but let me demonstrate true branch first. So you create a first branch. I create the name is energy, and I link to the S particle energy here, dot energy, and this system name is particle energy, and type is float. Another branch is position. The branch name is position, and this array, so I don't have ampersand, sorry, m operator here. So it's S particle dot position. Then this is I call it POS. Is has three elements, and each element is flow data type. So I create by true branch here. So and let me do it. Okay, paste it. All right, good. So let's see what happened. To say scan. Sorry, let's print. That's the top only. We have we have the two branch. One is energy, one is position. Now is had no entries here. All right, so we can fill the the entries by the same command field, and we set up some number here. So we say the S particle energy is 11, S particle position 0, 1, 2 is this value, and we fill it. All right. So let's see what happened. T scan. All right. So this is energy, and we have three position here. Okay, that's what we expected. Okay, so it's pretty easy. You just use the dot for the structure to access the variable inside and make a leaf according to the type of the variable inside here. So the same thing, let's demonstrate again. To, to get some value here, then fill it. So you can see this is the second entry here. Okay, so very good. Um, Another method is using not the the variable, but just the structure itself only. So the thing is, let's quick and to start it again. So we can have the definition of the structure. Then we create a variable according to that structure. And we create a tree. Now we want to link the variable to a tree by the branch method. So here I tell the root I want to have a branch called the particle info the branch name, and I want to link the variable as particle with its address. So in this cases here, if you use this way, this as particle and and would return the first address, the first variable address. So it would return you will return the energy here. So you have to put E first, not position first, okay? Because you will return the first energy, first address of first, sorry, the address of the first variable here. So you have to put energy first. I call this and leave is E for the first variable here, and the data type is F. Then I have position with 3 here. Okay, now let's review it. We create a structure and we want to link it. Then we use the branch and we call it the branch is particle info. Then we link the variable by ampersand because this is a structure. You need to use an operator to return the address, and the address will return the first one, the first variable address only. So it should be the flow data type for first. And I call this E as the leaf name. All right, hit enter. Cool, and done. So the same thing to fill it. So I just copy and paste. Good. So we supposed to see the right thing. But yep, you see the same. Okay, very good. All right. So here is the end of this tutorial by using the struct data type. The next one, a little bit more difficult, is using class. All right, so I think I will pause here and take a break. Alright, so let's go to the example 5 here. This will be the final example in this tutorial for demonstrating how to write into a tree here. So this will be the discussion about how to write an object from a class into a tree. So let me give you some very brief framework about what example 5 would do here. So first, you need to know the definition or some instruction from the class here. So you tell you the root, where to find the definition of the class. Then you declare a object from that class. Now we link the tree and a object here. Then we fill the data here. So step by step here now. I would like to go into the class here because you have to understand some very basic class idea in order to um, to understand how this example work here. Okay, so let's go inside here. This is particle class. I name it using the way I feel comfortable. Think so. This is CLASS that reminded me this keyword kind of class is not structural or another data type here. The h that h normally code the header file. Sometimes you it's because it's not a very complicated header, so I don't put another functions to CPP files. So normally you have a long method here, long function here. So in the header, people generally just put a function header, just describe the function, but the 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 contents will move to the CPP like particle class.cpp file here. But because it's a really simple class, so I don't do that. So let's take a look at what the class doing here. The particle class. So first, I include the class called tObject.h. This is from the CERN root file here, and because I want to use the inherit from this class here, so the second line tell you I declare a class here, and its name is particle class, and I inherit the public method from the T object here. This is not always necessary. This inherit is not always necessary. I only include it here because it kind of like a convention, and you have some you advantage like you can use the method like write like you can write into the root file by the method in the T object here, but I don't use it in this example, but it's good to include it here. Okay, so this word line just tell you I declare a class and I can use the method from the T object here. Now the thing here from here, the contents here is the class definition or some how can I say some content here. Okay, so it divided by two sections. One is private, one is public here. The private variable is the variable you can only access within this class here. You cannot directly accessible from outside the class here. Alright. So I will tell about that. So it's work like a global variable, but only inside this class here. So that means I declare a position and energy. I don't need to declare in the public section again because this is already a global variable, somewhat like this. So I can just direct it to having position 0 here. I don't need to declare anything because I already declare here. So this is private, is easy to understand, and this public, there are a lot of the thing element in this class. So every class has its own constructor. Constructor means when you use this class to create an object from this class, it will automatically invoke the constructor function, constructor method. So it's really necessary. In other language program like Python is always has this constructor here. But in C++ it's not always necessary. So now it's empty here. I do put anything there. So I have two variable and it's private. So I want to have some way to let outside the thing outside to communicate with this two variable here. So it's generally use a public setter or getter here. Setter means start from set like to set some variable here. So one is set position, one is set energy. So it's fairly easy. So the parameter is s, y, z. So you just assign s to the first element here. The y to second, z to the third here, just like a coordinate s, y, z here. And the set energy is pretty easy. You just energy will become to the parameter e here. So the getter is like to get the information from it. So if you use this function here, you would return position because this is an array here. This would be a address here. So you have to return a pointer here. So there is a star here. So I know the pointer may cause some confusion in a certain way here. But energy is pretty easy to understand. So energy is just float type here. So you declare function that's return type is float. Alright. So and there is a line here. This is special. Okay. So if you use the T object here or inherited here, you must include this line here. Okay. I don't know why, but this is the definition from the CERN root. Okay, so let's demonstrate how it look like. All right. So in the root, you can load by .l. And then I type particle class dot h. Now I supposed to be available to access this class. So I declare object from the particle class. It called S. How about this? So you have a way to access this object by its public method. Like let's say we set energy that we put into 10. Okay, so let's get this energy by this method, get energy method. You see 10, simple, very easy, right? Okay, so that's another one is set position. Let's say 1 1 2 2 2 3 3 3. Enter. Okay. So let's see what happened. We have get position. Um, Now it's remember this is array. Okay, so we put it this way. You see 1 1 1 here, 2 2 2 here. Okay, pretty good, isn't it? So right now you have some idea about how to use it. Okay, so you declare a class here. In order to let another program use, you have to create a kind of a share object, share, share object here. Then use the G system to load it. By the way, if you want to use this line, you can just directly in the interpreter, say interpreter here. If you want to write a code independently, you need to include the T system in order to use a uh, global pointer G system here. All right. So in this case, I need to create a share object. So the way to create is you type in dot x here, executive. Then file name is particle class dot h dot plus plus. Okay, now you're done. Okay, so you create this guy by this command here. All right, very good. Now we quit. Now we go to demo 2 here. So first thing, as always, we create a tree. Now we load some the class definition by this command gsystem load that we particle class h.so here. You need sometimes it will change because is .h now is underscore .h here. Alright, so you hit enter. So the thing is now after this now you have particle class. You can declare layer. The C interpreter knows that. So the next thing is if you link a object, there another special way to link it. So I the thing is the branch method as always. The first thing is the branch name. Now I call particle. Let's say particle info. Then is the address of the pointer itself. Okay, sorry, I forget to create I forget to declare an object. So I create a pointer called as particle, and the pointer can point to particle class. and I create this by new particle class here, and then type enter here. Let's just create a pointer to point that class. It's a somewhat different routine to link. Okay, so the next step is to link it to use a branch. Again, as I just said, I want to call it particle info here. Now I want to use the address as of that pointer particle. Okay, if I type it right, it should be fine. Uh, okay, good. Now it's good. So you create a pointer. You need to use arrow here, not a dot. So let's use the method. We just say set energy. That energy will become 11, and we use set position. Okay, so we change the value inside inside with a pointer. Then use the fill method. So we already got some progress. Let's see what we have. We can scan. Okay, there is something weird because this you have inherited to a T object, and here something is from the T object, is not from your data, so don't worry about that one. So you need to do is um, we set this position. Okay, that's what you have here. You see, this is 11. This is 1.1, 2.2, 3.3. That's what you have here. So because you get the T object here, so something here where is not really where because it's is from the T object. Remember here, this is a little bit different. You don't set out any leaf name or type. So when you link to a object, it would just automatically set out the branch name for you, what the leaf name for you. So you will have all the branch from the variable here. So because we inherit the T object, you will have some variable from T object here. So you will see something very different here. So you can also use get list of leaves. This was then print because if you don't have this, let me show you what happened. It give you a pointer, the point to the T object array. In order to see this, you have to uh, reference to its method called print. So you see this thing here is not necessary. It's not from our setting. It's just from the T object here. And this is a particle info is our name for the range here, and the position and the energy is a private variable inside the class here. And this is the position 3. That means there's 3 elements in it, but here is just single. I mean, there's a flow was very basic flow data type, so there is no other number in it here after that. So you can see very good explanation about how to make a class and link it, and you don't need to make all the connection between it. You just link the address of an object created from that class. You see, an address from this pointer point to this class, and it will automatically link all the branch for you. Okay, so you can also use start viewer. That's me in this T viewer here, or you use new T browser to see what happened here. So it's in the root here because we just use that. So you suppose in the memory. So here you see a T is a tree. Then the branch, because the branch name is we said particle info here. So there is another branch called T object because this is a class and this is another class here. We have position and energy. So far we just have one entries, and the energy is 11 here, and position is I don't remember the number here. Position is 1.1, 2.2, 3.3 here. Okay. All right. So you got an idea. So let's do one more field. Then we go to T browser. Okay. So refresh it. Yep, you have some value here. This is a very big one here. It's around 191, 291, 391 here. You update it. Energy is 99 here and 11 here. Get filled it. Alright? Very good. So I think you got an idea how to use it. And also you can see what happened inside by scan as I used that before. Remember, since you link to a class, it automatically set a leave for you. So the leave the name will be the same name as private variable in the class. So you will have energy and position as your leave here. So let's type energy RGY and position. Okay. Uh, sorry. Typing something wrong. Okay. Okay, so you see nothing because it's an array. Type 0. Type right, okay, this is better. So you got the position 0 is x direction, and you can put position. Okay, you have to be careful about typing. Okay, or you just say array. You see. So we have two entries. One entry is energy of 11. Second entry is 99 here. You see here 11, 99 here. The position of 1.1, 2.2, 3.3 here. Then the second position will 191, 291, 391. That's exactly what we want. So we link successfully here. All right. So this basically how to write a class into a tree here. So the final comment is a little bit the pointer tutorial here. So here we use the range method. The branch method requires you to first input the name of that branch. The second one is the address of the pointer. But sometimes pointer is memory to point to another memory. So it will sometimes is not so it's very clear. So let me demonstrate what is really meant about using an operator here. So let's try some very simple. So we declare integer x equal to 8 here, and we create a pointer, integer pointer, x pointer. to point the x, the variable s, you use the m means the address, because the pointer actually store the memory address, not the value here. So okay, so what it look like? You have uh, actually three-way to play with the pointer. So let's type this x pointer. So what it look like is this. Okay, it just give you some address, return some address here. So, but this address would identical to the address that's stored in the S. So you see, this is the value stored in a pointer, x pointer here, and this ampersand x is the value tell you where is the address of the x variable. So it just give you the idea. This guy will equal to this one here, okay, and x ampersand and operator operate on x will give you the where's the value stored in x pointer. Okay, but x pointer actually has its own address as well. Okay, so this is the pointer's address is this guy here, and in this memory here is still the value of this one, and this one is x, the x address here. So the final one is to dereference. It will be returns A. That means tell the pointer go to the address is point to, and tell mean where is the value of it is number 8. Okay, so here you return the address of pointer itself, not the other the thing that's pointer address point to. Okay, so this is the final comment about the pointer. I know this is somewhat confusing, but if you use a little for many time, you will know that. Okay, so sometimes I don't like pointer somehow because it make me sometimes make some mistake about it. All right, so I think that's all. That's what I want to say about how to store an object to a tree. I hope that will help you to understand more about the root as well. Thank you very much.